Year 5 Science. Hello everyone, welcome to my channel. Today we are going to continue our science studies, and today we will have some special experiments after a quick revision. If there are some technical difficulties during filming this video, then sorry about that. It's not that simple because I need to change different parts here, and I need to go to different parts of the classroom during filming all this. I would like to start today with the special symbols you can see here. These are special hazard symbols in the world of chemistry, chemicals and science. These are very important. You can see that they mean special things. Toxic, I would start with this one. If you see this symbol, that thing can kill people, so very dangerous. Irritant, if something is irritant or harmful, actually they can cause health problems. Usually you need to remove these things from your skin as soon as possible. You know the word radioactive, I think. If something is flammable, it can easily burn. Corrosive means that it can destroy tissues of the skin, and oxidizing means that it can react with oxygen, or the thing can also burn easily. Now let's move on to the next one. It's not that simple, as I need to change between different slides. Now hopefully it's going to work. What we learned so far is this. There are three states of matter: solids, liquids and gases. When a substance changes state, the particles gain or lose energy. Melting means that something solid turns into liquid. When freezing happens, liquid turns into solid. And boiling means that the liquid turns into gas. It's a kind of gain because the thing expands. Condensing means that gas turns into liquid. Now let's see some really nice animations here. When something is solid, you know the particles have a special kind of rigid system which cannot really change. If it's liquid, they can move around a bit, and gas can be everywhere in a certain container. We learned this thing as well. You know, all objects have different elements. We called them particles so far, but I would like you to remember that an element is a substance which contains only one type of atom. A compound is a substance in which two or more atoms are chemically joined together. And we have one more thing here. A mixture contains two or more elements or compounds that are not chemically joined together. Hopefully you can remember that last time we mixed green and white pieces of paper, and they couldn't really join chemically, of course. I could always separate the white pieces from the green pieces, so it was typically a mixture. You can see these special animations here. So only one type of atom, like chlorine, forms that. Is it a mixture? We will see. Two or more different types of atom chemically joined together. So, for example, water. Is that a mixture or a compound or an element? Two or more different types of atom not chemically joined together, like seawater, because I can separate the salt from the sea. If you can remember, we spoke about this. If you evaporate water, the salt remains there in a pool. This is how actually they produce salt in many countries these days. So let's see, if I place this here, that is actually not a compound because there's only one type of atom. In a compound, things chemically can join? No. So, two or more different types of atom chemically join together, and that is water. That's a compound. An element, two or more things are in an element? I don't think so. So only one type of atom, chlorine, is in it. And the mixture is when two or more different types of atom not chemically joined together. Today we are going to continue with compounds, water. I would like to show you an experiment with water. In this experiment, and I'm going to move my camera now, and I'm going to place it here. Hopefully you can see all the objects I prepared for you. Yeah, it's crucial. So, I would like to use some water, as we just said it. It's a compound. And we also have a candle in the middle of a plate, and I'm going to light this. You need that for burning, we need oxygen. Sorry about the noise. And I have a simple glass jar. Now the candle is burning. What is going to happen if I pour some liquid at the base of this candle, and I'm going to place this jar over the candle? Let's see. Hopefully you can see it well, that the water level rises instantly in the jar. Why? What happened here? And hopefully you can see the whiteboard now, where I summed up all the happenings of this experiment. So what are the physical aspects of our experiment with water? There was the candle which heats the air. Burning needs oxygen, so when the candle goes out, probably there's less oxygen in that jar. It's really logical, because burning needs all the oxygen. Air cools after this, but oxygen is used up. So the volume of the air decreases and the water level rises. There's less oxygen in the jar, there's more space for water there. Now that I started using some burners for our experiment, I would like to show you one more thing. If I change the structure of an object by using fire, probably I can have a change which cannot be reversed. For example, if I have a stick and I can start with a completely nice piece and I start burning it, I could actually change the structure of the wood, some physical attributions of it, and this cannot turn back. The change is irreversible, visszafordíthatatlan. Please repeat the word, irreversible, visszafordíthatatlan. If a special procedure is reversible, I can change it again. So, for instance, when I add sugar to water and the water evaporates, I can again have some sugar there. That was a kind of reversible procedure. One more thing. We learned about flames, fire. Can you remember how hot fire is? Yes, 1100 degrees, around that. What happens if something is warmer than its surroundings or the environment? Actually, the air can move upwards. Please open your book. I would like to tell you the page number as well. So you need for this the workbook, and in your workbook you can find a special kind of paper snake at page 137. If you cut this out, you can have a similar kind of paper snake like me. You can just place this paper snake around a stick, and your paper snake could turn over if you place this whole thing on a heater. The heat actually will move the paper snake around. Why? Because air expands when it's hot, so all the little parts of air, the molecules in it, will move upwards, so this can turn the paper snake around. Now, back to our display. Hopefully you can see this well now, and I'm going to close this presentation because you need to do certain things in your workbook. If you open your workbook, I will tell you the page number. At page 56 you can find a similar drawing there, and please draw here what happened in our experiment. You can draw here that the water level rises and the flame goes out. If you finished this task, you can continue with the next one. Under it, it's again on page 56. How can we prove that hot air rises? For help, cut out the paper snake on the last page of your book, and with a piece of string, hang it over the radiator or heater. Draw what happens. So please draw here that stick with the paper snake around it, and it can move around as heat flies up, and we can prove that actually hot air is lighter and it expands. It's lighter than cold air. And a quick reading from the book. I would like to tell you again the page number so you can read it with me. Page 66. Carved on wood. The difference between chemical and physical changes is that the inner structure of matter does not change during physical changes. Most physical changes are reversible. If you mix raisins and cranberries, you can separate them later. You can also remove salt from a saltwater solution. In the case of chemical changes, however, at the end of the reaction, one kind of matter will change into another kind, and these changes cannot be reversed. This change is irreversible. Everyday examples of chemical changes are burning wood or paper, baking a cake, boiling an egg, rusting of iron, fireworks, digesting food, and so on and forth. I would like to show you an image or two. For instance, if you check these pictures, you can see on the left a physical change. I just changed the size of the wood, yeah? And maybe the shape, of course. But the other one, when wood is burning, actually the structure of wood also changes, so it's a complete chemical change as well. What do you think about this one? Is it a chemical or a physical change? Actually, this one is also in your book. We call this tarnish on silver. When you can see this there, you will realize that actually the top layer of your spoons changed. So it's a special kind of chemical change. Oxygen in air causes a grayish-black covering, and this is what we call tarnish here. Now everybody reads alone this part in the book, page 67. Please underline the names of gases mentioned in it. I can see one already. Oxygen is definitely a gas, but you can find some more. So let's finish our class today. Today we learned certain things about compounds. We also revised certain things about states of matter. And we had two experiments here. The most important one was this. Please do not forget to write down all the important information which you could see on the whiteboard. You can go back in the video, you can find that part, open your science exercise book, write the date and the title, and sum up what happened when we had this experiment, the candle under the jar. Thank you. If you have questions, you can always find me by using your special e-napló, you know, Mozanapló, or you can just find me if you send an email to mihály.istván.okosuli@gmail.com. So, keep up good work. Bye-bye.